Alright, so this is number 5, and they want you to A, find the domain, and then for B, fill in the tables, and for C, discuss the behavior of F near any excluded values of X. So for number 5, we look at our denominator and see that the only value here that would make the denominator 0 is 1. So the domain would be all x such that x cannot equal 1. Okay, oops. Alright, so for part B, I put in the values in a calculator, and that's what I got, what you see there. So if you notice here, as x gets closer and closer to 1 from the left side, the value is getting smaller and smaller. It's going towards negative infinity. Okay, so as I wrote there for C, as x gets closer to 1 or approaches 1 from the left, then the function, then y, or f of x, I should probably write f of x instead. F of x goes to negative infinity. Okay, it's getting more and more, smaller and smaller and smaller, like more and more negative. And as x approaches 1 from the right side, that would be this side right here. See how I'm starting from 1.5, then 1.1, then 1. So I'm getting closer and closer to 1, but from the right side, the values here are getting bigger and bigger and bigger and bigger. Okay, so it's approaching, the function is approaching positive infinity. Also notice that as x gets bigger and bigger and bigger, here from 5 to 10 to 100 to 1,000, the value of y is getting closer and closer and closer and closer to 0. And same thing here, as x gets more and more negative, as I go to negative infinity, see how from negative 5, negative 10, negative 100, and so on, the value of y, or f of x, is also getting closer to 0 from the left side. See, negative 1/6, negative 1/11, negative 1 over 101, negative 1 over, so it's approaching 0, but from the left side, from negative values. Alright, so for number 9, I went ahead and factored the function, factored it, so that I could find the domain. So I see that x cannot be 1 or negative 1, right? Because if x is negative 1 right here, I get a 0, or if x is a positive 1 right here, I get a 0. So the domain is going to be all x such that x cannot equal plus or minus 1. For B, for the tables, I went ahead and input each of those x values into the equation, into the function, and then I rounded off the answers. I didn't put in all, because most of them, except for this one right here, the rest were all like non-terminating decimals. They just went on and on and on. So I just rounded them off. But it's enough to see a pattern. So for C, they want you to describe or talk about the behavior of the function as you approach the values of the excluded values. So in this case, it'd be plus and minus 1. So let's start off with plus 1. And I drew the graph down here. It's in your book next to the problem. I just forgot to take a picture of it. But it looks something like this, right? So as I approach 1 from the left, like I have written there, as I approach 1 from the left, so here's 1. As I approach 1 from the left and I'm following the function, notice how the graph is going down as I get closer and closer to 1 from the left side. So then that means that this is going towards negative infinity. As I approach 1 from the right, so here's 1 again, and approaching 1 from the right means I'm up here. So the graph, notice how it goes up. It's going to keep going up. It's not going to cross over. It's just going to get closer and closer to that asymptote, but it's going to increase. So this is going to go to infinity, positive infinity. Okay? As I approach x, as x approaches negative 1 from the left, as the function approaches negative 1 from the left, so here's negative 1, and this is the left side, so the graph is going up. Okay, so the function is going to positive infinity. And as I approach negative 1 from the from the right side, so here again, here's negative 1. This is the right side of negative 1, so it's going down. The function is going down. So it's going to negative infinity. Okay, so from 11 through 16, we have to match those graphs with the equations. So let me make this just a little bit bigger. Okay, so I look at number 11 and I notice that the denominator is x plus 2, so that means that x cannot be negative 2. So the vertical asymptote would be at negative 2. And the only function that has a vertical asymptote, and I'll draw it in blue, on negative 2 is a. Okay, so here's x negative 2, so that would be about here. So that's the only one that has an asymptote at negative 2, so this would be a. Number 12, the domain for number 12 would be all x such that x cannot equal 3. And the only one, again looking at the ones that are left, the only one that has an asymptote at positive 3 is letter D. So 1, 2, 3. I'm just going ahead and drawing it there. Okay, so the graph would be D for that one. Number 13. It has an asymptote at, well, it says all x such that x could not equal 0. But 14 is the same way, right? So 13, 14, it's between C and D. I'm sorry, C and E for 13 and 14. So let's skip those for now and go to 15 and 16. So number 15, the vertical asymptote would be at x equals 4, because that's the value that that would make the denominator 0. X equals 4. So letter B, 1, 2, 3, 4. Just counting across. So that would be about here. So B would be this answer right here for 15. And 16, negative 4, right? Because that's what makes the denominator 0 if x is negative 4. So count 1, 2, 3, 4. So that would be about here. So this would be F. Oops, that would be F right there. Now, in order to determine 13 and 14, you could plug in values of x to see which matches which, and like, does C go with 13 or with 14 and so forth. But remember, there's something else that we talked about today in class, the horizontal asymptote. Okay, and for that, notice that both 13 and 14 have the same degree in the numerator and denominator. So for 13, I would look at these two right here. Both of them have degree 1. So then the horizontal asymptote would be at y equals 4 over 1, because that's my A and my B. So y equals 4 would be the horizontal asymptote. And if you look at C, you count up on the y-axis, you count up to 4. 1, 2, 3, 4. You can, it's not drawn on there, but we can draw it on there. The line that goes across right there. So this one would be C. Whereas number 14, I've got these two as my leading terms for my numerator and denominator. And so this would be y equals negative 1 over 1 for my horizontal asymptote. And so that's equal to negative 1. And if you look at letter E, you go down to y equals negative 1, you can draw the line there, and there's a horizontal asymptote right there. So this would be letter E. Alright, so for 17, they're only asking you to find vertical or horizontal asymptotes, if there are any. So for vertical asymptotes, we look at the denominator. Okay, so there's nothing to factor or cancel here, no common factors in the numerator denominator. So what makes this a 0 is simply 0. So the vertical asymptote is x equals 0. As for horizontal asymptote, the degree on the denominator is bigger than the degree in the numerator. Okay, because the degree up here is 0 because there's no x, and the degree in the denominator is 2. So when that happens, then your horizontal asymptote is just 0, y equals 0. So for number 19, I'm going to go ahead and factor first. Always factor and reduce if you can. So right here, x plus 3 times x minus 2. Okay, and so the vertical asymptotes would be the values that make the denominator 0. So one would be x equals negative 3 and x equals 2. Okay, so those are the dashed lines that we would draw if we were graphing this function. And we look at, for the horizontal asymptote, we look at the degree of the numerator and denominator. In this case, they're equal. So for the horizontal asymptote, when the degrees on the top and bottom are the same, then you look at the leading coefficient. So it would be y equals 2 over 1, because that's the leading coefficient for each one, 2 over 1. Okay? And so 2 over 1 is just 2. So y equals 2. For number 21, they're asking for asymptotes and for any holes in the graph. So first off, we have to factor completely. So the numerator was already given in factored form. The denominator I can factor out in x, and then that'll leave me with 2 minus x. Okay? So the x and x is a common factor. This is a common factor, so that's going to create a hole. What makes that x 0? Well, 0, right? So then that means that 0 is 0, so then I'm going to find f of 0. So that's going to, and we cross it out, and so we're going to say 2 plus 0 over 2 minus 0, so that's 2 over 2, which is 1. So the hole is going to be at 0, 1. Okay, the hole is a point, so you have to give it in the coordinates. Now, as for any asymptotes, well, let's see the vertical asymptote, if it has one. We look at the denominator. And what makes the denominator 0? Well, that would be 2, right? So the vertical asymptote would be x equals 2. Then we look at the horizontal or slant asymptote. Because the powers or the degrees are the same of the leading terms, this one and this one, then when that's the case, we look at the leading, we look at let me write it right here. We look at the coefficients, leading coefficients, so that's going to be y equals 1 over negative 1, so that's negative 1. So here, that's your horizontal asymptote. Alright, so 23, we're going to